At 2:31 a.m. on March 30th, 2026, an Israeli Air Force F-35I Adir on a routine combat air patrol over the northern Negev desert was illuminated by a fire control radar. Not Iranian, not Syrian, Israeli. The AN/MPQ-53 Patriot battery at Ramon Air Base locked onto the aircraft for 11 seconds before the crew recognized the IFF transponder response as anomalous and broke the track. The pilot was not shot down, this time. But those 11 seconds triggered an investigation that produced a finding so severe that the Chief of Staff of the Israeli Air Force convened an emergency command conference at 4:00 a.m., 3 hours before the standard morning briefing cycle. The finding, the IFF, identification, friend or foe. Cryptographic codes used by every F-35I in Israeli Air Force inventory had been compromised. Not one aircraft, not one squadron, every aircraft. All 47 operational F-35Is that Israel has spent $6 billion acquiring and 15 years integrating into its order of battle. IFF is the system that prevents modern air forces from shooting down their own aircraft. Every military aircraft transmits an encrypted code in response to radar interrogation. If the code matches the expected response, friend. If it does not, unknown or hostile. The entire architecture of modern air warfare depends on IFF working correctly. Friendly fire incidents in previous wars. The USS Vincennes shooting down Iran Air Flight 655 in 1988, the Patriot battery that killed a British Tornado crew in 2003, happened precisely because IFF failed or was misapplied. When IFF codes are compromised, 3 catastrophic things become possible simultaneously. Enemy forces can disguise their aircraft as friendly. Friendly forces cannot trust their own IFF responses. And every air defense system in your own network becomes a potential threat to your own aircraft. All 3 are now true for the Israeli Air Force. To understand how this happened, and why the damage cannot be repaired in less than 72 hours of complete flight operations suspension, you need to understand what IFF actually is and where its vulnerability lives. IFF Mode 5, the current NATO standard used by the F-35, is a cryptographically secured system. The encryption keys are generated by the National Security Agency, distributed through a classified key management infrastructure, and loaded into aircraft transponders through a physical process that requires a cleared technician, a specific loading device, and a secure facility. The keys change on a rolling schedule, typically every 24 hours for the most sensitive codes, to limit the damage if any single code set is compromised. That is the theory. The practice requires that the key distribution infrastructure itself is secure. The loading devices are secure. The technicians with access are vetted and uncompromised. And the software on the transponders correctly implements the cryptographic protocol. Iran did not break the encryption. Breaking NSA standard encryption is not currently feasible for any known adversary. What Iran compromised was the key distribution infrastructure. Specifically, a software update pushed to F-35I transponder management systems on March 14th, 16 days ago, contained a payload. The update appeared to originate from the Israeli defense contractor responsible for domestic F-35I maintenance integration. It passed initial security scanning. It was distributed to ground support systems at 3 Israeli air bases, and it contained a dormant module that, when activated, transmitted the current IFF key schedule to an external server at 2:17 a.m. on March 30th, 14 minutes before the Patriot battery at Ramon locked onto its own aircraft. The activation signal was sent from a server in Turkey, routed through 7 anonymizing layers. The payload had been inside Israeli Air Force ground systems for 16 days before it was activated. For 16 days, every IFF key loaded onto every F-35I was being quietly copied and transmitted. Iran did not hack the F-35. It hacked the maintenance system. And the maintenance system had access to everything. If you understand why compromising a maintenance system is more damaging than shooting down an aircraft, subscribe right now. Because what I am about to explain is what the next 72 hours look like for an Air Force that cannot trust its own identification systems. Let me give you the operational numbers. Israel has conducted an average of 47 combat sorties per day since March 1st. F-35Is account for approximately 60% of those sorties, roughly 28 missions per day. These missions include deep strike into Iranian territory, suppression of enemy air defenses, escort for strike packages, and combat air patrol over Israeli airspace. At 4 a.m., the Chief of Staff grounded every F-35I in Israeli inventory. Immediately, all 47 aircraft, 28 missions per day, gone. The strike packages that depend on F-35I stealth for penetration of Iranian air defenses, cancelled. The combat air patrols that provide early warning against incoming threats, reduced to non-stealth aircraft that are more vulnerable and less capable. The escort missions that protect slower aircraft during strikes, eliminated. Israel's air operation just lost 60% of its most capable component, overnight, without a single aircraft being shot down. The 72-hour grounding is the minimum timeline. Here is what has to happen before a single F-35I can fly again. Step 1. Physical inspection of every aircraft's transponder hardware for signs of additional compromise beyond the software payload. This requires removing transponder units, shipping them to a secure facility, conducting forensic analysis, and reinstalling verified clean hardware. For 47 aircraft, with the available qualified technician pool, 72 hours minimum, more likely 96 to 120. Step 2. Complete replacement of all IFF key material. This requires coordination with NSA's key management infrastructure, generation of new key schedules, physical distribution through verified secure channels to all 3 affected airbases, and loading onto every aircraft by cleared technicians using verified, clean loading devices. The loading devices themselves must be inspected. If the malware accessed the loading devices as well as the management systems, the new keys are compromised the moment they are loaded. Timeline: 48 to 72 hours after clean hardware is confirmed. Step 3. Verification testing. Every aircraft with its new codes and clean hardware must conduct IFF verification testing against every air defense system it will operate near. Israeli Patriots, American THAAD batteries, Allied naval systems. Each pairing requires a coordinated test protocol. Timeline: 24 to 48 hours. Total minimum timeline before any F-35I flies a combat mission: 96 to 168 hours, 4 to 7 days. During those 4 to 7 days, Iran knows that Israeli F-35Is are grounded because Iran activated the payload. Iran knows exactly what it exposed, exactly what the response will require, and exactly how long the response will take. 4 to 7 days of degraded Israeli air power is not a coincidence in Iranian operational planning. It is the objective. Now let me tell you what the official response says, hence why, and where the gap is most dangerous. The Israeli Defense Ministry issued a statement acknowledging a cybersecurity incident affecting certain avionics support systems and confirming that a precautionary review of affected aircraft is underway. The statement did not use the word IFF. It did not disclose the scope, 47 aircraft. It did not disclose the timeline, 4 to 7 days. The United States Air Force, which operates its own F-35s and shares certain elements of the maintenance infrastructure with Israel, issued a statement that it was reviewing its own systems as a precautionary measure and had found no evidence of compromise in USAF F-35 systems. That statement deserves scrutiny. The malware entered through Israeli domestic maintenance integration software, a system specific to the Israeli configuration of the F-35I. American F-35 variants use different maintenance integration pathways. The specific vulnerability may not affect American aircraft, but the IFF key management infrastructure is shared. NSA generates keys for all F-35 operators: Israel, the United States, the United Kingdom, Australia, Japan, South Korea, Norway, Denmark, the Netherlands, Italy, and Belgium. If Iran accessed the key schedule for Israeli aircraft, the question that every F-35 operator is now asking behind closed doors is, did the access stop at Israeli keys, or did it extend further into the shared key management system? That question does not have a confirmed answer yet. And until it does, every F-35 operator in the world is conducting the same internal review that the Israeli Air Force conducted at 4 a.m. This is not a bilateral incident. It is a potential compromise of the most widely deployed fifth-generation fighter aircraft in the Western world, operated by 12 countries, with a shared cryptographic infrastructure. Let me give you the cost numbers. The Israeli F-35I fleet cost approximately $6 billion. Each aircraft is worth approximately $128 million. The compromised IFF codes cost nothing to create. The malware development and infrastructure required for the operation is estimated at $3 to $8 million total investment. $8 million to ground a $6 billion fleet for 4 to 7 days. Cost exchange ratio 1 to 750, but the financial cost understates the operational damage. 4 to 7 days of grounded F-35Is means no stealth penetration of Iranian air defenses. The strike packages that have been hitting Iranian missile production facilities, command nodes, and radar installations rely on F-35I stealth to survive the ingress. Without that stealth, those missions require suppression of enemy air defenses packages using non-stealth aircraft that are visible, targetable, and loosable. The operational tempo of strikes on Iran drops dramatically. Iran's military infrastructure gets 4 to 7 days of reduced pressure to reconstitute, disperse, and harden. No reliable IF across the Israeli air defense network. The Patriots, the David Sling batteries, the naval systems, all of them are now operating in a degraded identification mode, using secondary identification methods that are less reliable and more vulnerable to spoofing. The risk of engaging friendly aircraft is elevated. Commanders will be more conservative. Coverage will be more cautious. And caution in air defense creates gaps that incoming Iranian missiles can exploit. Here are the 3 options Israel is now working through. All of them involve trade-offs that did not exist yesterday. Option 1, accelerate the verification timeline, surge technician resources, run parallel work streams, accept higher residual risk on the hardware inspection to restore some F-35I capability within 48 hours rather than 96. The problem, accelerating the inspection means accepting a higher probability that some element of the compromise is missed. If a single loading device that was not fully inspected is used to load new keys onto a clean aircraft, the new keys are compromised within minutes of loading. The entire reset process must then begin again for that aircraft. Rushing the inspection to recover capability faster risks extending the grounding, rather than shortening it. Option 2, fly non-stealth aircraft in roles previously held by F-35Is, accepting higher aircraft and crew risk in exchange for maintaining operational tempo. The problem? The F-16Is and F-15Is that would fill the gap are not invisible to Iranian air defenses. They require SEAD, suppression of enemy air defenses, escorts that consume additional aircraft and reduce the size of the strike packages. Penetration routes that worked for F-35Is because they were undetectable do not work for F-16Is because they are not. New routes must be planned, deconflicted, and briefed. Planning timelines extend, and Iranian air defense operators, who have been watching F-35I ingress routes for weeks, will immediately notice the change in radar signature and adjust their own dispositions accordingly. Option 3, full operational pause. Accept the 4 to 7 day grounding completely, use the time to conduct the most thorough possible verification, and return to operations with maximum confidence in the integrity of the reset. The problem, 4 to 7 days of reduced air operations, is exactly what Iran planned for. Every day of the pause is a day Iran uses to move mobile missile launchers, disperse stockpiles, repair damaged facilities, and prepare the next phase of operations. The pause that protects the force also protects the adversary. Here is what you need to understand as we close. Iran did not shoot down an F-35. No adversary has ever shot down an F-35 in combat. The aircraft's stealth, its sensors, and its electronic warfare systems make it extraordinarily difficult to engage with any currently fielded air defense system. Iran found the one vulnerability that stealth cannot protect: the maintenance system that sits on the ground, connected to networks, updated through software pipelines, and accessed by technicians who are human beings operating in a world where supply chains are global and software provenance is difficult to verify. You cannot stealth your way past a compromised software update. You cannot electronic warfare your way out of a malware payload that has been inside your ground systems for 16 days. You cannot outmaneuver an adversary who has already been inside your maintenance infrastructure longer than your last 20 combat missions. $8 million one software update, 16 days of patience, and 47 of the world's most advanced combat aircraft are sitting on the ground while Iran operates freely in the airspace they were designed to control. Share this video, because the coverage will show you the Defense Ministry statement about a cybersecurity incident, and the precautionary review and the assurances that the situation is being managed. It will not tell you that every F-35I in Israeli inventory is grounded. It will not explain that the IFF compromise means every Israeli air defense battery is now a potential threat to its own aircraft. It will not map the 4 to 7 day window Iran just created in Israeli air power, or what Iran plans to do with it. They will give you the version where the incident is contained, and the aircraft returned to service and the vulnerability is patched. I just gave you the version where 47 F-35Is are on the ground. The maintenance system that services them was inside for 16 days. The key management infrastructure that 12 countries share is under review, and Iran got 4 to 7 days of reduced Israeli air operations for $8 million and one software update. The F-35 was built to be invisible to radar. Iran made it invisible to its own air force. $8 million, 16 days, 47 aircraft. The most expensive lesson in the history of software supply chain security, learned at 2:31 a.m. over the Negev desert.